Now, it won't be surprising that once we introduce a formula, then we can think of it, we can move to thinking in terms of algebra, formula, algebra, and we know that we frequently have to solve equations in algebra, and a formula is just an equation. So given the equation that L is equal to theta on 360, 2 pi and r, we know that we've got three variables. The L, the theta can vary, and the radius could actually vary of the Earth, because let me just demonstrate what I mean there. You know that when we've got the Earth like this, if we're on a circle up here that has a much smaller radius than obviously here on the equator. So here on the equator, we saw that the radius was this 6,400 kilometres, and that's what we're going to use for all great circles. But when we're up here on a small circle, the radius is much smaller. So the radius is a possible component that could vary. Now we know that in our formulas, when we've got three variables or three different pronumerals, the formula can be used to find any one of those. So we could be finding L, which we've already done an example of. We could be finding theta, the angle at the centre, or we could be given both those, and we could be finding, for example, the size of the radius of a smaller circle. In this question, however, we're told that it is a great circle. Being a great circle, the radius will be 6,400. So we know already that R is 6,400. And we're going between Sydney and Honolulu, and that distance, the arc distance, is 4170 kilometres. So you're probably realising the thing that we're going to be asked to find is the angle. It says, what angle is made at the centre of the Earth between these two cities? Answer to the nearest degree. So that doesn't come as a surprise once we've made the connection between this formula and it as an equation in algebra and needing to solve an equation. So we're going to substitute the values in just like we would in algebra. We don't know the angle, 360, and we've got 2 times pi, and the radius is this 6,400. There's quite a bit of tidying up, I would say, you can do there before we actually get started to solve. So 4170 is theta on 360 times, and I think we can do 2 times 6,400, which would give us 12800 pi. Now, it's just a little bit tidier, and you might be able to better see what needs to happen. To get this theta by itself, getting the theta by itself. So it's all about what's going on over here. You can see that we've got to divide by 360. Well, we certainly don't want that, so we would do the opposite, which is multiply by 360. So we would multiply by 360, and that will cancel this out. Fantastic. Now, we don't want to times by 12800 or pi, 12800 times pi. And if you're not using the new calculator, please make sure you bracket that. And we over here need to divide by 12800 times pi. Now, what the markers have told us is that students get this far, then they don't use their calculator correctly. And that is why we've gone to the new calculator. So with the new calculator, yep, I think we can just squeeze it in there. We want a fraction. Obviously, we want a fraction. Turn it on. Whoops. And get our fraction. On the top, we want 360, and we want to multiply that by 4170. Move to the bottom of your fraction. Now, this is the advantage of this calculator then, in that you don't need brackets anywhere. And down there, we want 12800 times pi. Nice. Finished? Press equals. So they're saying the angle at the centre between those two cities would be this 37.3. Now, does that say to the nearest degree? Yes, it says to the nearest degree. So again, like in the previous example, I'm not going to write that all out because I keep losing the picture. So I'm just going to go straight to rounding, which would be 37 degrees. And I'll stop the video there.